Okay. Yes. I was telling you about the chlorine, and you know what? Why we are taking the abundance into account? Because otherwise, just by the isotopes, you cannot calculate the atomic mass. Okay, this is the formula. What is the formula? That firstly, atomic mass of the first isotope, then its abundance. Okay, you will multiply these two. The atomic mass of first
Mhm.
isotope, okay, whatever the first isotope is, and its abundance. You will multiply these two. For example, if you talk about the chlorine 35, this is first, right? What is the atomic mass of chlorine 35? Can you tell me? Atomic mass,
So,
chlorine
like that.
35. Hmm?
The, oh,
Sorry, I can't hear you.
the atomic mass is what's it called 35.
Yeah, it is 35. Okay. Then, what is its percentage? They have told us what they have mentioned here. What is the percentage of chlorine 35 in the Earth crust?
75.
No, no. 35 is mass. What is the abundance?
Like
Abundance.
75% of
Yes,
atoms in
yes,
chlorine have.
yes. Chlorine 35. If you talk about the both of these chlorine, collectively, if we talk about, so there will be 100. Total, there will be 100, right? So from those 100, 75 on the earth crust are of chlorine 35, okay? And 25
Yeah.
are of chlorine 37. This is what they are telling us. That which one is abundant? This one is abundant. Chlorine 35 is more in number. Okay, it is present in more
Mhm.
quantity as compared to the chlorine 37. Clear?
Yeah.
Okay. This we have right that 35 is the atomic mass of the first isotope as well as its abundance is 75, right? Then plus, this is the
Yeah.
plus sign, plus. Now what is the atomic mass of second isotope? Can you tell me the atomic mass of this second isotope?
Uh, Second is 37.
Yeah, it is 37. And what is its abundance? They have mentioned.
25%.
Yeah, it is 25%. Okay. So this is how you will calculate it. Can you calculate this and tell me what is this? What will be the answer?
Oh, okay.
35 into 75. What will be this?
Yeah, plus 30,
Mhm.
okay, so 37, 35 plus 75 would be, uh, what's it called? 2,625 plus
Mhm.
37 times,
25.
yeah, that would be 925.
925. 9,000. 37 into 25. How it
Yeah,
can be
it's
925?
925.
So how it is more? I think there is a mistake.
Mm, no,
37.
no, because
35 multiplied 75. It is 2625.
no, it's
Okay.
25, not 75.
Okay. Yeah, okay.
Yeah,
So what
yeah,
will be the
plus
total?
2625 would be 3,550.
Yeah. So that is 3,550. Then what will you do?
Yeah.
You will divide it by 100 because what you are doing, you are calculating from the 100%. Okay. You are basically we are taking the percentage. Okay.
Yes.
25%. Basically there should be 100 over here because it was in the percentage. Okay. It was in the percentage. So if you take the percentage,
Yeah.
it will be 26.25. It will be 9.25, right? And it will be 35.50. Clear?
Yeah.
So what is the mass of the chlorine? 35.5, right? This
35.
is what
Yeah.
we take when we calculate, when we do the numericals, we take it 35.5. Are you clear with this?
Yes.
Okay, let's do another example with if they have mentioned an imaginary number has isotope 30%. This one. Okay, we can do this. An imaginary element has two isotopes. 30% of its atom have mass of 45. Okay, but they have mentioned 30%. Firstly, what is the mass? What is the mass of the atom 1?
45.
45. Okay. That is 45 into what we will write 45 of the 30%,
30.
right? 30%. So 30 divided by 100, right?
Yeah.
Plus
Yes.
The
40,
yeah
48
48,
plus 48 times 30.
not 30. They are saying the
Um,
rest have a mass of 48. I told you there will be a
yeah.
total will be of 100. Okay, total will be of 100 molecules.
Mhm.
100%, from 100%, 30% are of mass 45. Okay, 30% molecules are of mass 45, and rest of the molecules are of mass 48. Right. So how many molecules are left behind if 30% are 45? If 30% molecules are
70.
of, yeah, 70%. So the 48,
Yeah.
the mass of with the 48 will be 70%. Okay. Now can you calculate this
Yes. Okay.
and let me know what is this?
Okay.
Okay. Yeah. And then 30 and
Yeah, I
hmm,
finished.
what's that?
Yeah. The answer is gonna be 47.1.
47.1.
7.1.
Okay,
Yeah.
calculate. Explain why both the isotopes Z react in the same way. Okay, why? Yeah, this is the discussion which we have already done in the previous meeting. They are saying why both of the isotopes react in the same way. Now they are actually talking about the chemical properties, right?
Yeah.
Can you tell me now?
So like explain why because
Hmm.
maybe because they have like what's it called? They won't react too much.
No, they are saying why both isotopes react in the same way. React in the same way. What I told you about the reaction, which property tells us about the reaction? Hmm?
Uh,
Bonding
yeah,
pattern,
yeah,
right?
yeah.
And how we get to know about the bonding pattern?
From the what's it
Hmm.
called? How much electrons are there in
Yes,
the
in the
configuration?
in the valence shell, yeah. The electronic configuration and the
Yeah,
valence shell electron tells us about the bonding pattern. So why they
yeah,
both are acting in a similar way? Because they are isotopes, and in the isotopes we have discussed that there are same number of what we can say there are same number of electrons, right? So in the two
yes,
isotopes, electron number is same. It means the electrons in their valence shell will also be same, right?
same.
And those electrons will decide the bonding pattern. Since both of the isotopes have same number of electrons in the valence shell, that's why they both will react in the same way. Clear?
Mhm.
Are you clear with this?
Yes, yes.
Okay. Now they have mentioned the three isotopes. We can do the exercise now, and yeah, this one. What are the isotopes? Now, can you recall what are isotopes?
Isotopes are something that have different types of different neutrons, but same protons and
But
electrons.
we say we don't mention the definition like this. We say isotopes have same atomic number, but isotopes are the atoms of the elements. Okay, atoms of the
Hmm.
same kind of
Yeah,
element. What is the same kind of element? Just like carbon. Carbon is an element, but its atoms are
yeah,
different.
like different forms
Yeah,
of
yeah. On
yeah,
what basis? What
but
is
they
the
have the
definition?
same number of
Hmm.
so like they
Same
have like the
atomic.
different type of elements, but they have the same atomic number
Yeah, you will mention
and
whenever
different masses.
whenever we are going to discuss the definition of the isotopes. We will mention that whether the isotope, we will discuss it in the terms of atomic number and atomic mass. So you know that the isotopes
Hmm.
have same atomic number but different mass number. So your definition should be isotopes are the atoms of the elements with same atomic number but different mass number. Okay,
Yeah.
okay. Part B. Name the three isotopes of carbon and write the shorthand symbol for them. Can you name them?
Um. Uh. Name the three isotopes of uh that are carbon 12, 13, and 14.
14. And how we will write it? We will write like this. Carbon 12,
C12
yes.
and
6,
yeah,
then
C, yeah,
always write
13,
a
6
proton
and
number as well, the atomic number and mass number, both. Always write these two things, okay? Because we have discussed over here, this is the standard form. You see, this is the standard form. You will write the nucleon number, over here you will write nucleon number, over here you will write just the proton number, okay? Okay,
yeah.
now, next question. The three isotopes of oxygen can be written like this, oxygen 16, 17, 18. State the number of protons and neutrons in each. Okay, now, this is important. Yes. Oxygen 16, if we talk about the oxygen 16, wait a minute,
Uh,
let me take a snapshot and we can do this on one note. That will be easy. Mm, okay. Yes. Okay. So you have this question. Firstly, oxygen 16, 17 and 18, right? Now can you
yeah.
tell me if we talk about the oxygen 16, if you have oxygen 16, right? There is 16. How many protons will be there? And how many neutrons will be there? For this, okay, for this you must know what is the atomic number of the oxygen. You know what is the atomic number?
Atomic number of oxygen,
Hmm.
it's 8.
Yeah, it is 8. Okay, so you know this. Now can you tell me the number of protons in it?
Protons 8.
Okay, number of protons are 8. What about number
Yeah.
of
Neutrons are also 8.
neutrons are also 8.
Mm.
Okay. Electrons will also
Oxygen
be,
17
yeah, now we have
is 8.
oxygen 17.
17.
It will
Neutrons
be,
are 9, but protons and electrons are 8.
hmm, 8, this will be same. The proton number is 8, right? And the neutron number is
Yeah. 9.
9. We have oxygen
Yeah.
18, proton number is what?
What's it called? 8.
8. And neutron number?
Neutron is 10.
10. Okay. So this is simple question. Very simple. So the number of proton, hydrogen is its first element in the periodic table, has three naturally occurring isotopes. They have 0, 1 and 2 neutrons. Write the shorthand symbol for these three. This is very important. They have mentioned hydrogen has three naturally occurring isotopes. It has 0, 1 and 2 neutrons. How many neutrons are there? If we talk about the hydrogen, there is hydrogen, this hydrogen. They have mentioned neutron number is 0, then neutron number is 1, then its neutron number is 2. Can you tell me what will be the proton number and what will be the what can be in the subscript and what can be in the superscript? What will be Z for this?
Hydrogen, it should be
For this one.
1.
What
No,
is
it will
it?
be no 0 0.
If it will be 0, then will it exist? You are saying neutron is all. They have mentioned neutron number is 0. Read the question. Read the question. What they have
Yeah.
mentioned. They have mentioned hydrogen is the first
3.
element in the periodic table. Has three naturally occurring isotopes. They have 0, 1 and 2 neutrons. Okay, like there are three isotopes. One isotope has 0 neutron, the other one have 1
Mm.
neutron, and the last one will have 2 neutrons. Okay, it has 2
Yeah.
neutrons. So 0, 1 and 2, I have mentioned these. Now I am asking you about the proton number. Think about it.
So it will have 1. It will have
Yes,
1.
If you will say that 8 proton number is 0, it means it will not exist. Because there is no species in which neutrons are 0 and in which protons are
Yeah,
0. It means you are saying
I
nucleus
mean,
is, there is no nucleus. This is not the case. We have nucleus.
yeah,
Hydrogen has a nucleus. So it will be 1. And what will be the mass?
yeah.
Mass number. What will be the mass number?
1.
Yes. How we calculate the mass number? A is calculated by n plus z, right? The number of protons
Yeah,
and neutrons. Clear? Are you clear
neutrons.
with this?
Yes.
Okay, now can you tell me
For the
what is?
second one, it would be 1 as well.
Yeah, good. Now what will be this?
And what's it called?
It will be one. Proton number is
Last
one. What is the
number,
mass number?
yeah, would be 2.
Yeah, it will be two. What about the this one? Last one?
This one, it will be proton would be 1, and what's it called? The mass number would be 3.
Yes, the proton will be one. Proton are also always same. Okay. So this is known as, this is what it is known as protium, isotope of hydrogen. This is known as deuterium.
Mm-hmm.
There can be spelling mistake, and this is known as tritium. Okay. So these are the three isotopes of hydrogen. Okay. There,
Yeah.
sodium, deuterium, and tritium. Okay. Then we have next question. Now they have mentioned that write the shorthand symbol. These are the shorthand symbols. This hydrogen, hydrogen. Okay.
Yeah.
What does AR stand for? Yes. What does AR stand for?
Uh, Relative atomic mass.
Yes. So R is from relative. That means we are talking about relative atomic mass. Which atom is used as a standard for working out AR?
Which
Which,
atom is used for?
hmm,
Like, is
hmm,
it what's it called?
hmm.
Carbon?
Yeah, definitely it is carbon. Why are you confused?
Yeah. No, no. I thought it was also oxygen as well.
No, no, no. You will always compare with carbon 12. I told you carbon 12.
Yeah, always use
Not,
carbon 12.
yes.
Yeah.
We always compare the other species with the carbon 12. Okay. So which atom is used as standard? That is
Well,
carbon.
even if it's like oxygen, we always compare it with carbon. Yeah.
Yeah. So will every other atom of the element will be compared with the carbon 12. Okay. Carbon 12 is the standard.
Uh, yeah.
It is an international standard. Okay. Okay. Now they have mentioned
Mhm.
what is R in the AR. What is R? What does the R in the AR tells you?
The 112, like the relative.
Yeah. It tells us the mass is relative to the carbon 12. Okay. Tells that mass is
Yeah.
relative to carbon 12. Okay. Okay. Now next question we have. Write down the definition of AR and make sure you understand each part of it. Yes, what is relative atomic mass?
Um, it's like the average mass of an atom of the
Mm.
element compared to
Mm.
the R, which is the 112th of the carbon 12 atom.
Yes, we say that relative atomic mass of an element is the average mass of its isotope. We have calculated the average mass, right? Average mass of its isotopes compared to the carbon 12 atom. Okay, I am writing it. You can
Yeah.
take the screenshot. There's, it is the relative atomic mass AR is the average mass of isotopes of an element compared to the carbon 12 atoms. Clear?
Yeah.
You can take a screenshot of this, or maybe it is written on your book. Okay. Are you done with this?
Yes, yes.
An imaginary element has two isotopes 30% explained by both isotopes of Z react in the same way. Yeah, this we have done, right? We have done this part. Calculate its AR. We have done all these. In the homework, I will give you some of the questions of some of the numericals. Okay, you have to do that. Or there will be three or four. Okay.